हम्म, तो नहीं तो खाना खा लो तो तुमको ज्यादा नहीं खाना लगी। कल की रोटी सुबह बची हुई थी, सुबह खाई ब्रेकफास्ट में खाना नहीं खाया। हाँ मैं खाऊंगा, देखता हूँ। मोटे का फोन आ रहा है शाम का है, सुबह दोपहर को आने के लिए कहा था, और मैं कहा भाई मेरी तबीयत डेली हो रही है। टेम्पल कह रहे जाने के, मैं टेम्पल तो मैं नहीं जाऊंगा। शाम को आप लोग हुआ हो तो जीविया चलते हैं तो भाई टेम्पल वगैरह घुमाओ। मैं थोड़ी ऐसी हो रही है तो थोड़ा बेटर होगा। ये शाम को देखते हैं, कुछ ना कुछ शाम को शायद वो आएगा। मैं दालों की मंगाऊंगा, तो समझ आ रहा है। गुस्सा हो रहा था। मिस कर रहा हूँ तुम्हें बहुत। मिक्सिंग बाबू, मिक्सिंग बाबू। हाँ, हाँ भी दिक्कत है, गौर नहीं हो बच्चे भी। सुबह की लेट होती है, सुबह में तो लेट कर सकता हूँ। फिर दाल रोटी खाऊंगा तो हिम्मत नहीं होगी कुछ। फिर लगा। हम्म। हाँ, खिचड़ी और दलिया। अब ऐसा लगा बस लेटा रहूं, बस लेटा रहूं। हाँ, वो नेशनल नोट करने का क्या है यार ये, तो ध्यान कहीं होगा। दवाई वही खा नहीं रही है, इसके साइंसेस काम करती नहीं है दवाई के बिना। संभाल नहीं पाती अब, वो तो बच गई कुछ। ऐसा नहीं वो कुछ ज्यादा नहीं वो बात करते, वो चीजें तो और भी हो जाती खराब। तुम्हारा क्या है? तो वो भी लग सकती थी ना, वो तो बच गई, मतलब ये है कि फिर भी हाथ पैर में लग गई इतनी ज्यादा, तो मतलब ब्लड आ रहा है। तो काफी टाइम में मुझे टेंशन गई, तो हमारी फिर नींद नहीं आई, मुझे पेन में लगा होगा उसको। मस्ती नहीं है, क्या पता मैं उसको। अभी कैसा है? पैर वाला तो मैं ज्यादा तुम्हारे लगा है, मुझे लग रहा है वहां ज्यादा ब्लड आ रहा था। और एक एल्बो में। साइड में करके। हाँ, वो रहेगा अभी। 2 दिन में रहेगा। दवाई लगाई दोबारा? डॉक्टर को इंजेक्शन लगवाने गई थी, वहीं से कुछ करवा ली थी पट्टी वगैरह कुछ? नहीं, वो बताया था ना कि ये ट्यूब लगा लो, उससे ज्यादा फर्क पड़ेगा। इंजेक्शन कहाँ लगाया, हाथ पे? हाँ, अभी यहाँ भी दर्द हो रहा होगा। कुछ भारी चीज मत, भारी चीज मत उठाना कुछ। कुछ हैवी चीज मत उठाना। और खट्टा मत खाना भी, बाहर जाओगी ना, दर्द बढ़ जाएगा। खट्टे से दर्द उखड़ आता है। गोलगप्पा, जलजीरा, नींबू वाली चीजें अवॉइड करना है। तो उससे पेन एनहांस हो जाता है, खट्टे से ना। कुछ हल्दी खा जाना कुछ हो। जो दिन वो मिलता है ना, कॉर्न मिलते हैं वहाँ पे, कॉर्न अच्छे होते हैं। जैसे कि मैंने कॉर्न ऑर्डर तुम्हारे, रबड़ी फलूदा होता है उसके पास, स्वीट वाले के पास। टिक्की छोले होते हैं, टिक्की खाओ। सामने जो मॉल सा है उसके अंदर खाने पीने का सामान है, वहां पे देख लिया। मॉल में खाने की जगह भी है तो बहुत कुछ। अभी जाना है? कल बताऊंगा। हम्म, ऐसे जब खाओगे तुम। हम्म, जब खाओगे तुम तो ठीक तो कर लो अपने आप को। जादू से हो जाएगी। क्या कहो यार, यार मतलब कट गया, दर्द हो गया। हाँ, दिमाग भी ठीक नहीं है अभी। नहा तो लिया ना, जल चढ़ा था ना संडे को। नहा तो मैं सुबह लिया था, आज 10:30 बजे करीब नहा लिया। जल चढ़ाया, फिर अपना थोड़ा खाना वाना खाया, जो भी ब्रेकफास्ट किया। तुम जल चढ़ा रही हो तुम? क्या है बेटा तुम्हारी? मैं बोले काम तो चाहिए तुम। हम लोगों को बाहर इलाका। हरिओम तब से। सामान लेना जो भी लाना है ना? सामान ले आना जो भी लाना, शॉपिंग वॉपिंग करो। साड़ी की हो गई, कुछ और चाहिए तो धवल के लिए कुछ 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 भिजवा देना। धवल मूसा जी के, सुरभि जी के लिए, तुम अपने हिसाब से। बूंदी देखना, मतलब शॉपिंग में जा ही रहे हो तो कुछ उसके लिए लेके, उनके लिए मासी जी ले जाएंगे। ठीक है, देखना क्या सही रहेगा, जो भी उसको पसंद है, मासी जी को पता होगा, ले देना। ग्रूट। हाँ, मैं मंगाता हूँ उससे, बॉम्बे बैठ से सोच रहा हूँ वो मंगा दो, रोटी दाल रोटी वही से रहती है, मुझे वही सूट करती है। बाकी सब मसाला वसाला बहुत होगा। शाम को वो आएगा, देखते हैं जैसे भी होगा बता देना। और दोपहर को ही आया था वो तो 1 बजे, मैंने मना कर दिया, मैंने कहा तो तब कैसे हो फिर शाम को आता हूँ भाई। वो वहां पे जाता है, मंदिर जाने की क्या लगता है जबेदारी।
Guys, so guys, any idea? Do we have a class today or not? Anybody got a message from Ram sir?
No, no message.
I think we can check over WhatsApp or somewhere because I'm not sure. It's already been more than 25 minutes.
Guys, can you hear me and can you see the screen? Can someone please post on the group? Ask others to join as well.
Sure, sir.
Yes, can hear you and also screen is visible.
Okay, cool. We'll wait for 2 minutes, then we'll start. Guys, does anyone have any questions from the previous session? Yesterday, what were we doing? Anyone? We were doing questions on arrays, and specifically we were focusing on some 2 pointers and some sliding window, right? Okay, and we did a few questions. We will continue doing the questions, but today we will start a new topic, okay, which is called linked list. So I hope you have the context of linked list. It's also a data structure, just like arrays. Okay. So in our journey of learning about data structures, guys, all of you can see the screen, right?
Yes, sir.
Okay. So in our journey of learning about data structures, I did not give you a classification of how we are going to learn, although I told you that we are going to learn what data structures. I told you we will be learning array, linked list, stack, queue, then trees, graphs. But if we look at the classification of data structures, we have linear data structures and we have non-linear data structures. Okay, so within linear data structures, we have the most important one, which is array. Why I say array is very important, because the concept that we are using in array, that is universal concepts, that is going to be applied other places also. Techniques that you are going to use in array is going to be applied in many places. Even when we are solving dynamic programming, there also arrays will come. When we are discussing strings, there also array concept of array will come. When we will discuss about hashing, there also array will come. Okay, and if you are learning about linked list, stack, queue, everywhere the concept of array is going to repeat. That's why array is something that we learned in the beginning, and array We'll constantly keep encountering. Okay, the questions on arrays will constantly keep coming. Okay, so we started with array, then we'll talk about linked list. By the way, I did not tell you that what do I mean by linear data structure and non-linear data structure. That we will discuss. Okay, then we have stack, and then we have queue. And when we talk about non-linear data structure, okay, first we have trees, then we have graphs, and we have priority queue, or you can say heap. Okay, we also have some hash maps. So some places you will see hash maps under linear. Okay, some places people will say it is non-linear, but we will keep it separate, and we'll say hashing based. Okay, we will say hashing based. So here we will have hash set and hash tables. So today we are going to, till now we have focused on arrays. This is what we have discussed till now. Okay, and we will do a quick recap of array now, and then we will start with linked list. Is it clear, guys? Once we are done with linked list, we will quickly do stack and queue also. Then our linear data structures will be complete. And again, we will do some practice sessions parallelly how we are doing. And then we will move to trees. Okay. When we move to trees, you will start enjoying more, because then you will have little bit confidence also, and you will have good understanding of data structures. Okay. So our first milestone will be to complete our linear data structures. Hopefully in the next week or next 3 classes, we'll try to complete this. And then we will start with non-linear data structures. Let us target that by end of this month, we should complete these non-linear data structures also. Okay, graphs will take some time. Graphs and trees, there are a lot of concepts, but at least basics we'll try to cover this much. Okay, by end of this month, which means next 8 classes. Next 6 classes already. This is the second class of this week, right? Okay, guys, everyone clear? Everyone with me so far? Okay, let us start with linked list. So if you see linked list, I think I already gave you some intuition of linked list when we were discussing about introduction to data structures, and I was trying to paint some difference between what is a array and what is a linked list, and contiguous and non-contiguous, scattered memory, all of those things I think we were discussing. But today let us start again our discussion of linked list from scratch. I hope all of you are able to read my handwriting. I think it's very bad. Okay, chalo. So what happens? So let us try to discuss about. We'll talk about linear, non-linear. Lucky Agarwal. I'll tell you. Okay. So when we were talking about arrays, okay, when we were talking about arrays, there are few things that I told you. The first thing was that it is stored in contiguous block of memory. Okay, and the second thing was that accessed by index. Okay, and cache friendly. Okay, these are the things that we discussed in low level array. And then contiguous block of memory को solve करने के लिए we also talked about referential data structures. Accessed by index, it is possible only when it contains the same data types. Containing same data type. But sometimes we want to store some other data types also. So in that case, we use referential arrays or lists. Okay, and access by index and cache friendly, and size is fixed. So contiguous block size is fixed. Therefore, we also talked about dynamic arrays, right? This is what we have discussed with arrays. We also discussed some demerits of arrays. Okay, what were some demerits of arrays? That insertion and deletion was not very efficient. Not very efficient. Accessing is very efficient. Okay, so this is the context that you have to keep in your mind, that this is what we have learned so far. And in terms of representation, we saw that an array is represented like this in a block of memory. Okay, and we are having some memory address like 2012, 2016. Okay, 2020, 2024, and 2028. And there are some values here we are keeping. Okay, so suppose here we are keeping 10, here we are keeping 20, here we are keeping 30, here we are keeping 40, and here we are keeping 50. Okay, and because these data types are of the same type, therefore we are able to index it using pointer arithmetic. All of you remember, if we keep track of where is the first index, and if we want to find out which is the third value, then we will take the first address 2012, and we will take how much memory is being stored by each element, which is 4, and how many times you want to jump. So we want to jump 3 times. Okay, so this way we are able to reach to 2012 plus 12. So we are able to reach 2024, which is this one. This we are using pointer arithmetic. This is how we are doing accessing. Now, what is linked list? In linked list, this is contiguous. Okay, in linked list, we don't store things in a contiguous way. Okay, so if I have to represent the same thing, whatever I have done here, if I want to represent the same thing in a linked list, okay, what I will do, I will create these locations 10 somewhere, okay, in whatever memory location I like, and then 20 in whatever memory location I like, and 30 in whatever memory location I like, 40 somewhere randomly, and 50 somewhere randomly. Okay, and what I will say is that 10, and for this reason, okay, for this reason, we also say that this is sequence of elements. Okay, and you can traverse it in one direction only. Okay, that's why we also call that, we say that this is linear. From 10, you can only go to 20, 20 you can go to 30, 30 you can go to 20. You can traverse in only this way. This is the sequence. Okay, either you can access it this way or you can access it this way. This pattern you will see in array also, linked list also, stack also, queue also. Okay, so if we are, so I was talking about linked list. Sorry, not like this.
ए अभी टेबल पे मेरे चश्मा जरा दोगे?
Okay, so what I'm saying is that I will store all the elements randomly in a scattered way. Then how are they going to behave as a sequence? They're going to behave as a sequence because 10 will contain the address of 20. So if suppose 10 is stored in a memory location called 2000, and 220 is stored in a memory location called 3000, and 30 is stored in a memory location called 2500, and 40 is stored in a memory location called 3500, and 50 is stored in a memory location of 1000. Okay, so what we will say is that 10 will contain not just the value 10, but it will also contain the reference address of the next element. Okay, so this 10 will tell us where 20 is going to be. In case of an array, 10 does not need to store that information because we know that 10 contains 4 bytes, 20 will be 4 bytes after that. That's why it is contiguous. But in linked list, that is not the case. We will say that 10 is going to store the address of 20, 20 is going to store the address of 30. So when we go to 10, we will also see that what is the address that 10 is holding, and 10 will tell us where 20 is stored. Okay, so how will that look like? It will look like this. 10 will not just store 10, it will also store 3000. Okay, and 20 will not just store 20 will also store 2500, and 30 will also store 3500. And 40 will also store 1000, and 50 will not store anything, because after 50 there is nothing, so it will have none, null, whatever you want to store here. Okay, so when we have this type of structure, we will also represent it. When we are drawing it, we are not actually concerned with the memory location, whether it is 2000, 3000, 5000, whatever can be memory location. We are never going to be concerned about that. So we will represent it like this. We will say it is 10, and 10 is telling us where is 20, and 20 is telling us where is 30, and 30 is telling us where is 40, and 40 is telling us where is 50. So a common way to represent a linked list is using this arrow. Okay, this is only for our understanding. It's not just for us to represent and differentiate it from arrays. The arrow represents that this 30 is telling us where is 40, 40 is telling us where is 50. 50 के बाद कुछ भी नहीं है, तो यहाँ पे हम लोग ऐसे ड्रॉ कर देते हैं, ऐसे उसको नन बोल सकते हैं. Okay, all of you are with me so far? Now you can ask me that, sir, fine, but what actually is this thing? Whatever you have drawn here, what actually is this thing? Is it an integer? Is it a float? What actually is this container? Okay, so we will define this container as a node. We will say this is a node. This concept of node will be there with you as long as you are studying data structures. Okay, in tree also it will come, in graph also it will come. This is a node, or you can, some places it will also be represented in a circle like this. 10, 20, 30, 40, and 50. Whether you draw a circle or a square, that does not matter at all. Okay, but this is called as a node. So node is a data structure that we will define, a very minimal data structure that we will define. So this node will contain two things. It will contain data, and it will contain reference to next data. This will contain two things. So node will look like this.
So ये जो नीचे representation है, तो that is how we represent. ये जो ऊपर explanation आपने दिया जिसमें reference हो रहा है next node का, that's for understanding. But अगर हम represent कर रहे तो it's like this जो नीचे आपने लिखा है.
कौन सा, ये वाला?
हाँ, ये या फिर square में anything.
कैसे भी करो, स्क्वायर बनाओ, सर्कल बनाओ, से कोई फर्क नहीं पड़ता.
अच्छा, ओके.
जब ट्री वगैरह पढ़ेंगे ना, तो वहां पे लोग सर्कल बनाते हैं नोड के लिए.
ओके, ठीक है.
मैं नॉर्मली, मुझे आदत है स्क्वायर बनाने की, तो स्क्वायर बना दिया, उससे कोई फर्क नहीं पड़ता. ठीक है. तो एक जो नोड होगा ना, जिसको हम बोलेंगे, इसमें दो चीजें होंगी. ये हम डिफाइन करेंगे, ये कि हम एक कस्टम डेटा टाइप बनाएंगे पाइथन में. मैं बताऊंगा कैसे करें. ठीक है. इसमें दो चीजें होंगी, इसमें दो ऐसे स्ट्रक्चर बनाएंगे, और इसमें दो पार्ट्स होंगे. अगेन मैं ये सब दिखाने के लिए बना रहा हूँ, ऐसे दो पार्ट्स बनेगा नहीं, वो तो एक डेटा टाइप होगा, उसमें दो चीजें स्टोर करेंगे, बट ऐसे रिप्रेजेंट करते हैं. यहाँ पे हम लोग एक नोड बनाएंगे, और इस नोड में एक जगह पे हम लोग डालेंगे डेटा, और एक जगह पे इसको बोलेंगे नेक्स्ट. नेक्स्ट मींस एड्रेस ऑफ द नेक्स्ट नोड. ठीक है. तो ये एक नोड होगा, इसको हम बोलेंगे दिस इज नोड 1, दिस इज नोड 2, दिस इज नोड 3, this is node 4, and this is node 5.
Sir, इसमें like if we lose any address, that means we will lose out whole linked list.
Yes.
After
Yes.
that one, right?
जी.
Okay.
अगर आप नोड 3 खो दोगे तो नोड 4, नोड 5, नोड सब चला जाएगा. तो ये इस चीज का हम लोग ध्यान रखेंगे. आगे जाके हम लोग जब इस लिंक को तोड़ेंगे, जोड़ेंगे, ऐड करेंगे, डिलीट करेंगे, तो इन चीजों का हम ध्यान रखेंगे. पर आप जो बोल रहे हो सही बोल रहे हो. Shashwat is saying, sir, we needed OOPS concepts to create this custom data structure. Yes. ठीक है. तो अब यहां पे अगर हम नोड 1 का बात करें, ठीक है, तो नोड 1 डॉट डेटा अगर मैं पूछूं तो क्या है? व्हाट विल बी नोड 1 डॉट डेटा?
सर 10.
10 है।
हाँ.
और मैं पूछूं कि नोड 1 डॉट नेक्स्ट, कुछ लोग एनएक्सटी लिखते हैं, कुछ लोग एनईएक्सटी लिखते हैं, फर्क नहीं पड़ता। नोड 1 डॉट नेक्स्ट विल बी नोड 2,
टू.
तो वो मुझे नोड 2 तक पहुंचा देगा। फिर जब मैं नोड 2 पे पहुंच जाऊंगा तो मैं बोलूंगा कि हाँ भाई वैल्यू बताओ नोड 2। तो नोड 2 का जो डेटा होगा, तो ये डेटा क्या है यहाँ पे? ये डेटा और नेक्स्ट क्या है? दीज आर एट्रीब्यूट्स, इफ यू रिमेंबर अवर ऊप्स। ओके, नोड 2 डॉट डेटा बोलेगा कि मेरा वैल्यू तो 20, और नोड 2 से पूछूंगा कि भाई तुम्हारा अगला नेबर कौन है, तुम्हारे बाद मैं किधर जाऊं? तो बोलेगा कि मेरा नेक्स्ट एट्रीब्यूट देख लो। तो नेक्स्ट एट्रीब्यूट बताएगा कि नोड 3 है। नोड 3 पे जाएंगे, नोड 3 मेरा वैल्यू देगा और फिर बताएगा अच्छा नोड 4 पे चले। ओके, डिड यू गाइस अंडरस्टैंड द कॉन्सेप्ट ऑफ नोड?
Yes, sir.
Someone is asking why we are using linked list. Navneet is asking, very good question.
नोड बनाते क्या हैं?
Node, guys, till here everything is clear? Now, by the virtue of what we have discussed so far, few things are coming to our mind. Few things are coming to our mind. One is that, okay, that if we have, so here data will be scattered. Okay, not contiguous. So whatever demerits we were having, whatever demerits we were having with array, that contiguous होना चाहिए, उतना मेमोरी स्टोर करना पड़ेगा, उतना अगर हमें if we want to create an array of 10, then we have to allocate a memory of 10. If we want to add another element after 10, then we have to do resizing. We have to go and look for another bigger set of memory which can accommodate more elements. And then we saw that in dynamic array we can use some kind of geometric additions of new memory addresses, so that when we are storing more elements, we keep a buffer to store more elements. So we were doing so much of work. Okay, but if the data is scattered and there is no need for this contiguous property, then we will feel little bit relaxed in terms of adding some elements, removing some elements, क्योंकि हमारे पास कोई लिमिटेशन नहीं है कि हमें 10 ही चाहिए, 20 चाहिए। डायनामिक है, जितना मर्जी ऐड करो, नोड ऐड करते जाओ, as long as you have memory. You don't have to bother about contiguous memory. So data is scattered. So if data is scattered, then insertion, deletion is better. But the problem is that accessing is slower, because we need to traverse from first node, और फर्स्ट नोड को हेड भी बोलते हैं, ये मैंने नहीं बताया आपको। ये जब हम यहाँ पे डेटा स्ट्रक्चर बना रहे हैं यहाँ पे, तो जो फर्स्ट एलिमेंट है इसका, इसको हम लोग बोलते हैं हेड। ओके, हेड के पहले कुछ भी नहीं है, देयर इज नथिंग बिफोर हेड, एंड दिस इज कॉल्ड एज टेल। ओके, टेल के बाद नन है, टेल डॉट नेक्स्ट विल बी नन। ओके, वॉट एवर इज द लास्ट एलिमेंट, दैट इज टेल। दिस इज क्लियर, हेड एंड टेल?
Yes, sir.
These three lines are clear to everyone, what I said? एक्सेसिंग क्यों स्लो होगा और इंसर्शन डिलीशन बेटर क्यों होगा? साइज will have dynamic nature. Okay, fixed size of array, fixed size, we can add any number of elements. We will have to, Shashwat is saying we will have to access all elements before that to get to that element which you want. Correct. Okay, guys, till here does anyone have any questions? Contrast between linked list and array.
एक स्केटर का एग्जांपल दे सकते हैं? स्केटर का क्या मतलब हुआ, मतलब कि कौन किस तरह का डेटा रहेगा उसमें?
स्कैटर का मतलब ये हुआ कि जब हम array बनाते हैं तो array में डेटा स्कैटर्ड तो नहीं होता है ना, इकट्ठा होता है। ये इसका पड़ोसी होगा, ये इसका पड़ोसी होगा, ये इसका पड़ोसी होगा, चारों इकट्ठा रहेंगे जहां भी रहेंगे। जब ये भर जाएगा 10, 20, 30, 40 भर गया, अब आप बोलोगे कि यहाँ 50 डालें, तो यहाँ तो जगह नहीं है। ऐसा तो नहीं कि यहाँ पे एक मैं नया घर बना के 50 डाल दूंगा, ऐसा नहीं कर सकते। तो क्या करना पड़ेगा?
तो
एक
हमने
दूसरा
लिस्ट में तो मेमोरी इंक्रीज हो जाता है ना, एरे में फिक्स रहता है। यदि हम लिस्ट यूज करते हैं तो
लेकिन कैसे इंक्रीज हो जाता है?
वो ऑटोमेटिक रहता है ना, जितना डेटा डालेंगे उतना इंक्रीज होगा।
ऑटोमेटिक हो जाता है, ये कोई जवाब नहीं हुआ। ऑटोमेटिक कैसे हो जाएगा? होगा क्या ऑटोमेटिक? मतलब क्या? ये 4 एलिमेंट कंटिग्यूअस है, अगर मुझे एक नया एलिमेंट डालना है तो मैं एक दूसरा फिर से एक नया ब्लॉक लूंगा और यहाँ पे 10, 20, 30, 40 और यहाँ मैं 50 डालूंगा। तो ये एक दूसरा मेमोरी लोकेशन था, ये था मे बी 2000, 2004, 2008 और 2012। जब यहाँ 5th एलिमेंट डालना पड़ा मुझे, ये जगह नहीं मिला, तो ये प्लॉट मैंने छोड़ के मैंने दूसरा प्लॉट खरीदा और उस प्लॉट में जाके मैंने यहाँ पे सपोज ये था 5000, ये था 5004, ये था 5008, ये था 5012 और ये था 5016। जहां भी यह है तो कंटिन्यूअस। ऐसा तो नहीं है कि मुझे यहाँ पे आप बोलोगे 60 डालने के लिए, तो 60 को मैं कुछ 1000 मेमोरी लोकेशन पे डाल दूंगा और उसको मैं इस एरे का पार्ट बना। आई विल ऐड, इट्स नॉट पॉसिबल दैट आई विल ऐड, इफ आई वांट टू ऐड some new element here, if I want to add some new element here, it's not possible for me to create this 1000 somewhere in a random location and then make it part of this array. That is the basic thing, that is the first thing that we discussed about arrays, that it is contiguous. Now what do I mean by scattered? Scattered means that if I want to convert this to another data structure, I will have a liberty of having it scattered in the memory. 10 can be somewhere, 20 can be somewhere, 30 can be here, 40 can be here, and 50 can be here. I don't have to put it in a contiguous manner. Then we can link it. We can say 10 go to 20, 20 go to 30, 30 go to 40, 40 go to 50, like this. We created a chain. That's why it is called as a linked list. Did you understand the meaning of scattered, Navneet?
Yes, yes.
Anyone else has any question? Shouldn't node1.next should be ID of node2.data? See, that is an abstraction. Where is that memory location? That we don't have to bother. It will point to node 2. Everything is pointing to some memory location only. When I say node 2, what actually is node 2? Node 2 is referring to some memory location only. So we don't have to see ID of node 2. And we are not interested in the ID of node 2. In an array, are you ever interested whether the memory location was 2000 or 2004 or 2008 or 2012?
यहाँ पे नोड का मतलब क्लस्टर से रिलेटेड है क्या? ग्रुप ग्रुप क्लस्टर बनाते हैं, डिफरेंट डिफरेंट है तो
Cluster?
नोड का मतलब क्या हुआ? मतलब लिंक कर रहे हैं, इसके लिए वो नोड बन जा रहा है ग्रुप में।
ये जो एक चीज मैंने यहाँ बनाई, ये जो यहाँ पे मैंने बताया ना, ये दिस एक जो मैंने यहाँ ब्लॉक बनाया, इस ब्लॉक को मैं बोल रहा हूँ कि एक नोड है। Node is nothing but it is a data structure, or you can say it is a memory location which contains an object. Node is an object. एक ऑब्जेक्ट है। इस ऑब्जेक्ट में दो चीजें स्टोर होती हैं, एक डेटा स्टोर होता है और एक नेक्स्ट पॉइंटर स्टोर होता है। एक समझ लो कि मेमोरी में मैंने एक ऐसे बॉक्स बना दिया एक मेमोरी लोकेशन में। पाइथन का एक ऑब्जेक्ट है ये, पाइथन का नहीं, मतलब पाइथन में कोडिंग कर रहे तो इट विल बी पाइथन ऑब्जेक्ट, बट इट इज अ डेटा टाइप। हम लोग जब oops पढ़ रहे थे तो we created some data types, right? Humans, cricketers,
Yes, sir.
students, school. We created ATM, banks. We created a lot of employee. We created a lot of data types, right? Similarly, node will also be in Python. It will be a data type, user defined data type. Okay. In that custom node, we will have two things. We will have data and we will have next. Next will contain the address. Okay. So someone is saying if it is address, then it should be ID. ID, it's not needed. If you just say it is node 2, this is node 1. If you just say node 2 itself, when I say node 2 is a variable name, but internally it is pointing to some memory location. So we don't have to say ID of node 2. That's not needed. समझ में आ रहा है?
हाँ सर.
आगे बढ़े?
Yes.
Okay. Now there are some common operations. So when we say linked list as a data structure, okay, when we say linked list as a data structure, so when we are trying to implement it, let us now talk about कि इतना जो मैंने ज्ञान दिया यहाँ पे, इतना जो यहाँ पे ज्ञान दिया कि ऐसे बनाएंगे वैसे बनाएंगे, we will make some nodes, we will link the nodes, and it will have a next pointer, all these things. Okay. So how are we going to implement it? How are we going to implement it? So linked list does not exist in Python by default. Okay. So we have to implement, we have to do a Python implementation of linked list. Okay. But before doing Python implementation of linked list, we have to make up our mind that what is going to be the model of a linked list, or what are the things that are going to be kept in a linked list. Going forward, we will also call it as a data type or abstract data type. Okay. Abstract data type basically tells us the logical model of a data structure. What operations can be performed on that data structure. So if you remember about abstraction, in abstraction, when we were learning about abstraction, I told you that abstraction is all about two things. One is interface and one is implementation. Okay. Interface tells us the promise. Okay. Interface tells us the promise of what something is going to look like. What are the buttons that are going to be there, which I'm going to click. For example, interface of a mouse. I gave you that this is the interface of a mouse. This is a mouse. It has buttons. It has a scroll wheel. This is the interface. And there is the implementation of how that buttons are going to work. Okay. For example, if you talk about array or a list in Python. So a list in Python has what operations? Okay. It has insert. It has append. It has delete, remove, pop. Okay. So we say this is the interface. We say that a list should have these things. But actually, how it is being implemented in the backend? How it is being implemented in the backend?
It is storing addresses of
Using arrays. Concept of arrays. So when you say that create a list, what will Python do? When you say create a list, Python will create a list and it will give you. But behind the scenes, what is happening? Python will take some memory space. Python will talk to the memory allocator. If it is based on some C language, it will run some C code. It will take some memory. In that memory, it will assign some values. It will take some buffer. All those things will happen. But those things are hidden from us. We actually don't care. In fact, when you have been using list so far, you did not even know about arrays, but you were using list. That is only abstraction. This is the interface. If I want, I can implement this whole thing using some other concept also. We are going to see that the same ideas, it can be implemented also using linked list. The performance will be here and there. If you do using arrays, some performance will be better, some operations will perform poorly. If you do using linked list, some operations will behave differently, some operations will be efficient. But the list can be made using array also, can be made using linked list also. So when we define the model of how thing is going to be, okay, that is what you call as an interface. And in data structures, the same thing we will call it as an abstract data type. If you have understood abstraction properly, you will be able to appreciate it. Okay. If you're a little bit confused, ये concept को आप थोड़ा छोड़ भी सकते हो, कोई problem नहीं. ठीक है? So if we want to create a linked list, first we want to make up our mind that what are the operations that will be there in a linked list. Okay. So first we will want to create a linked list. How we will create, that is our headache, we will see. Implementation we will see, but first we want to define that what are the things that are going to be there in a linked list. For it to be called as a linked list, there should be a linked list. Okay, then we should be able to add elements to the linked list. Okay, we should be able to remove elements. Okay, add elements, remove elements. Then we want to traverse. We should be able to find the size. Okay, then we should be able to what to do. We should be able to search, traverse, or search. Okay, so these are the things that we should be able to do. If we create our linked list, then that linked list implementation should have these things. Now we have to talk about how it will have these things. How are we going to implement? So this is the interface. Now we'll talk about implementation. So how are we going to implement it? So here I've given the heading Python implementation, but actually we are not just talking about implementation, we are talking about interface and implementation. Okay, so how will we create? First, what we will create, if suppose if I'm saying that I want to create a linked list like this, 10, 20, 30, and 40. I want to create this. And here, where is the head? This is my head and this is my tail. Guys, is everyone following so far?
Yes.
सबको समझ में आ रहा है?
हाँ sir.
Ramesh ji has not joined today.
Yes, sir. I am able to see this.
Oh, sir, hello. Sometimes you are Ram and sometimes you are Ramesh. Okay.
Yes, both are same only that.
Okay.
Yes.
Okay. You are able to follow,
His
sir?
short name, someone called me as a Ram.
Okay.
Usually, but my full name is Ramesh Kumar.
Okay. Able to follow, sir? So far? Chalo. So what we will do, first we will define a node. First we will create a node. So we will create a class for a node. So first we will create a node data type. So whenever we are working with trees, linked list, graphs, okay, we'll usually try to create a node. The requirement for the node can be different. Today we are learning linked list, so it is we have to have a data and a next. It can have few other things also depending going forward. When we will learn about trees, then it will have a left, right, all those things will be there, but the concept is going to be same. We'll create a node data type. Okay, this is a lightweight data type. So how will we create a node data type? We will say that we will create a class called node. Okay, and we will write one init. Okay, and we will say self.data is equal to data and self.next is equal to none. Okay, so this is our definition of a node. What have we done? We have created a new data type called node. So now what we can do? If we want to create this structure 10, 20, 30, 40. So what I can do? I can create a node. I can say node 1 is equal to, I can create this object node and I can say 10. Okay, and I can create node 2. So what this will create? If I do this, then what will happen? It will create a node which will have value of 10, and here there will be nothing, because next by default I'm putting as none. Guys, is everyone following?
Yes, sir.
Okay, then I will say node 2. I will create one node 2, and node 2 I will say again one object of node which is 20. 10 ke baad 20 tha? 20. So what this will do? This will create इतना कोड अगर हम लोग लिखते हैं तो हम लोग क्या क्रिएट करेंगे? यहाँ पे एक नोड यहाँ पे मैंने क्रिएट किया 10, और इसका जो नेक्स्ट डेटा वाला दो पार्टीशन में बना रहा हूँ, एक में डेटा एक में नेक्स्ट। आई होप उतना समझ में आ रहा होगा। ये बना दिया मैंने, और उसके बाद एक मैंने 20 आई क्रिएटेड 20, दिस इज 20 एंड दिस इज आल्सो नन। ओके, देन व्हाट कैन आई डू टू लिंक देम? कैन आई से दैट node 1 dot next is equal to node 2? अगर मैं ऐसा लिख देता तो क्या होगा? यहां पे node 2 आ जाएगा। Here I will have node 2, which means that what we have done, we have created 10 and I have linked it to 20. We have done this much work. We have done this much work. Is this clear, guys?
Yes, sir. So, but it's kind of the static, right? If you are going to create the 10 node means, do we need to repeat the code? Node 1 dot next, node 2 dot next. So how many times can we write?
We'll come there. We'll come there. But I'm happy
Yeah.
that you are pointing out the inefficiency of what I'm doing. Thank you. Correct. That means you are thinking in the right direction. But this is how we will do it. Not manually like this. Okay. So what can we do? Instead of doing this like this, should we write one method? So till now we have only created this node and we are doing this manual work. Okay. So instead of doing this manual, but did you understand this much? If you have understood this much, then you have understood Python implementation of a linked list.
Yes, sir.
Okay. So what we will do, instead of doing this, we will create another class called linked list. Where we will assign head. Head of what, Priyanka ji? हेड तो होता है लिंक लिस्ट का। लिंक लिस्ट तो अभी तक बनाया नहीं हमने तो बस दो नोड बनाया, दो नोड को जोड़ दिया। कैसे जोड़ेंगे वो मैंने बस बताया। ठीक है, अब हम लोग बनाते हैं लिंक लिस्ट। नाउ लेट अस क्रिएट अ लिंक लिस्ट। व्हेन वी क्रिएट अ लिंक लिस्ट विल हैव अ हेड, करेक्ट? नो? So when we create a linked list, we can create a linked list here. We can say started raining. Okay, we can say init. We can say self. Okay, and if you want to create a linked list, what do you need? We can say that we need a head. Okay, and we can do self dot head is equal to head. By default, we can put this as none also. Or you can skip it, also. Self dot head is equal to none, and we'll say self dot size. Yeah, isko none hi rakhte. Let us not take it. It's up to you how you want to design it, but standard is that you don't have a head. Okay, and by default you put head as none. Okay, and you have self dot size is equal to 0. So what does this say? This is our basic linked list we have created here. So if now I come here and if I say that I will say my list is equal to an object of this linked list, class linked list, this one. Okay, linked list. Then what is this my list? We will say that this my list is a linked list. A linked list of size 0, which means it does not have any elements. So when a linked list is not having elements, then we say that there is a none. Okay, and the none is only head, and the none is only tail. This is an empty linked list. You can say that, sir, no, we don't want to create like this. Whenever we create a linked list, we will always have a head. So then you can do that also. Here you can pass one head also. You can create a node and you can say linked list, and you can pass head is equal to node 1. So in that case, it will be node 1, whatever that node 1 is, maybe it is 10, and you can say this is my head and this is my tail, because this will be 10 and none. So you can say this is linked list with only one element. You can create like that also. But normally when we create a linked list or a stack or a queue, normally you will say we'll create an empty one and then we will add to that. Okay. This is a linked list with one element. Now you will say that, sir, in a linked list, there is a head also and there is a tail also. But here you are putting only head. Why not tail? Okay. So tail also we can track. Normally we will not track a tail. Okay. Sometimes there is a need for tracking tail also. That we will see a little bit later. Okay. So you can have self.head also, self.tail also if you want. But when we are doing the first implementation, then tail is skipped. You can also do self.tail is equal to none. So there are some benefits of tracking tail also that we will see in a little bit time. But I hope in Python, how we are going to implement it, this is clear. Now you will say that, sir, in a linked list class that you have implemented, this is only having the constructor method, which means how to create a linked list. And when we are creating a linked list, you are not adding any nodes. So we are creating an empty linked list. But after that, what? We have to do something. We have to add something to this linked list. Maybe we want to add 1 element, 2 elements, 3 elements, 4 elements. Then we want to remove some elements. We want to delete from the beginning, delete from the end, append, pop. Many things are there. All of those we have to do. So all of those methods we are going to add in this class. This is only the constructor. Okay. But ideally, we will write the class that I will not write here. We will write it in Jupyter Notebook. But I'm just giving you the high level picture. that we will create
So do we need to write two classes for the linked list? Which one you have written latest
why
one?
two
and-
classes? Where two classes?
No. You have first of all you wrote one class right in the top.
Which class?
Scroll up.
1 second.
Yeah, this is one for you have written latest one. Then previously you have the top one.
Node.
Class node, yeah.
Why have I written this node?
Yeah, that's my question. Why did you write two classes because you have already defined the data, right? Self.data.
This node is going to be used in the linked list. How will you make a linked list?
Yeah,
What
that's why
will you-
both classes, node and linked list, both are the different classes, right? Both are mandatory or for one linked list.
Listen. When you will create a linked list,
Yeah,
what will you add in a linked list?
head and tail
You will add nodes, right?
nodes. Yeah, yes, correct.
So how will you add node if you don't have a node? For that, you have to first create a node.
Okay, yeah. Yes, correct. Linked list have the nodes. Yes, correct.
Node is the ingredient which will make linked list. So first we need to have the ingredient. We have to prepare the ingredient. Okay. First we will create the dosa batter. Then using that batter, we will create the dosa. Correct. So this is the ingredient. This is the batter. And this is what? This is dosa. So when we are writing this class called linked list, here ideally we will add methods. We'll add a method called insert. We will add a method called delete. We will add a method called search. And like that, we will add many elements. So that will be our implementation of linked list. So when you are inserting in a linked list, what will you insert? You will say that in the linked list, insert node 3, something like that. And here there will be a code to insert it. I want to delete. Which node I want to delete? I want to delete node 5. Which element I want to search? I want to search for node 10. Okay. So we will work with nodes inside linked list. All of you are clear? Yahan tak, is anyone having any confusion or doubt?
Sir, we are inserting the node under the same class, right? The linked list class. Then do we need to also create the separate class node as well? You have written in top.
Yes.
That is pointing to the node, initialize the node, right?
Yes. This node 3 from where it will come, Baba? This node 3
Okay.
from where it will come? You will create a node 3 like this, no? Node 40. Then it will create a node which will have element 40 and here it will be none. So this node will come from where? This data structure will come from where? We have to define it, no?
Okay. Then in this case, you need to have the separate class, right? Class node.
Yes.
Yeah, right.
Should we write some code in Python?
Yeah.
Yes or no? How many of you are following and how many of you are confused? Those who are confused, write confused.
Yeah, if you
Those of
write
you are
one
clear,
program,
please say clear.
it's clear, sir. If you write one program, we can get it. Or
Achha.
we grade it.
We will write. Give me 1 second. My terminal is messed up. Guys, we'll take 5 minutes break.
Okay, sir.
Yeah, yes, sir.
6:25. We'll be back at 6:30. Okay. Guys, we'll start. All clear with me? Okay. So we want to implement a linked list. Or if you can see the screen. Guys, screen is visible. Implement a linked list. So first what we will do. First we will create a node. How will we create a node? We'll write one class node. Okay. And we'll write a constructor for this. Okay. And we will say this node will take a data. Okay. We'll say self.data is equal to data and self.next is equal to none by default. Okay. Now I can create node 1 is equal to node. I'm taking value 10. And I want to create another node called node 2. I can say this is node 2 called 20. Okay. So now if I look at node 1, it is looking like this. Because I have not given any representation to this node. Okay. But you can add some representation, but I don't want to add anything right now. So I'll just say node 1 dot data and I will say node 1 dot next. So node 1 dot data is equal to 10 and node 1 dot next is equal to none. Okay. But now this is not a linked list because linked list itself has to be one entity. We have just created nodes and we are just adding nodes here and there. So now we want to also create a linked list data type. For that, we'll create a linked list. Guys, do you know, appreciate why we were spending so much time on OOPS? OOPS is enabling us to create whatever we want. So if we have learned something in the theory, we have learned some concept in theory. And now we want to implement that. We want to create that in Python. So we are free. If we understand what we want, if I know what I want to build, then I can create it very easily using my understanding of object-oriented programming. Okay, नोड बनाना है, नोड का कॉन्सेप्ट समझ में आया, चलो नोड बना दिया. लिंक लिस्ट बनाना है, ठीक है, लिंक लिस्ट बना देते हैं. लिंक लिस्ट नोड से बनेगा, ठीक है सर, बना देंगे. You are free to create whatever you want, customize whatever you want. Okay, so I'm going to create this linked list. In it, self. When we were learning OOPS, some people were asking, sir, why are we learning OOPS? I hope you are now getting the answer. At that point of time, I would have told you that just learn OOPS. The requirement or need for OOPS, you will understand later. So those people, whoever were asking me, I hope now you are getting your answer why we were learning OOPS that time. Okay, we'll do self dot, will not add anything here, and I will just say self dot head is equal to none. I'll say self dot size is equal to 0. Again, size optional for you to track, but standard ways we track the size also. So this is what we have created. I can say that my list is equal to, I can say linked list, and I can pass nothing, and I can just say my list dot type. It will say that my list is a type of linked list. Okay, and I can say my list dot head. It is right now it is none. Okay, so now what I want to do next, I want to append some elements in this. So I want to give you a node. Okay, and I'm saying that I've created this linked list, and this linked list right now is empty. It is just, I've just created none, and this is my head and this is my tail. Okay, but I'm saying that I want to create one node. Suppose 10, and I want to add this 10 to this linked list. Are you guys understanding? So currently this linked list is empty. this linked list is empty. Forget about this. Suppose you are already having a linked list. Suppose you are having a linked list called 10, 20, 30, and 40. Okay. And I'm saying that there is a new node called 50 and I want to insert it towards the end. That's why I'm saying append. Append means what? Adding towards the end. Is the problem statement clear, guys? What I'm trying to do here? Can we explore this and understand, and then we can write the code?
Yes.
Okay. So let us try to understand this logic. This logic will be very, very important for you. These things are very, very fundamental things. Okay. So please pay attention. Okay. So I'll talk about till now whatever work we have done, you are clear. We have created, we have learned about basics of linked list, and then we understood how do we implement linked list. We create a node, we create an empty linked list, and now we want to add something to the linked list. We want to grow the linked list. Okay. So we are going to talk about common operations on linked list. शाश्वत रुक जाइए तो 2 मिनट में आपको सब समझ में आ जाएगा. So the first thing is append. Okay, or you can say insert at end. So what is the logic? So let me say that I'm having one linked list like this: 10, 20, 30, and 40. And my task is that I want to create a new node called 50, and I want to add it to this linked list. This is none here. Is the problem statement clear, guys? Can someone tell me how we will do this? Of course, here, this is my head and this is my tail. What are we going to do? Tell me. Guys, can you hear me?
Yes.
What we will do? Bataiye. Tell me.
We'll
If I want to add 50, tell me, Ramesh ji.
we will use append method. No?
Append method. Append method from where? That's what we have to write. Once is saying travel from head till last node and add new node. If I want to add this 50, what I have to do? I have to join this 40 to this 50. Is that not correct? I want to join, I want to create one link from 40 to 50 like this. And 50 ke baad to none hai hi, because when we create a node by default, the next of any node is none. So if we can point 60, 40 dot next ka 50, if we create this, suppose this is node 1, this is node 2, this is node 3, and this is node 4. If we are able to do node 4 dot next is equal to, suppose this is new node. If we are able to do node 4 dot next is equal to new node, then our work will be done. Correct? So now question is that how are we going to get to node 4? How will we get to node 4? For that, we have to come to node 3, because node 3 will only tell us where is node 4. And for node 3, node 2 can only tell us where is node 3. And for node 1, node 2, only node 1 can tell us where is node 2. And node 1 we already have, because head we are tracking. In the linked list, we already know head. Okay, so what we can do? We can put one pointer here
We need to traverse from head to next.
To next. Okay. So I'll put one pointer here, and I will call it the current pointer. Okay. And what I will say that if current dot next is existing, if current dot next is there, then go there. Then I will ask current dot next is there. It is there because it is 30. I'll say go there. I will say if 30 ka next is there, then go there. Okay. 40 ka next is there. Currently it is not there. Currently this is not there. Okay. Currently it is like this. If current dot next is none, that means we are standing at the tail. Do you agree, guys?
Yes, sir.
Okay. So what we will do? We will say that we'll try one logic. Okay. We'll say current is equal to head. We'll say current is equal to head. Okay. And we'll say while current dot head. We'll say current is equal to current dot next. These type of operations you will do very, very commonly when you are working with linked list. I hope my voice is clear, guys.
Yes.
What is this doing? This is moving the current pointer ahead. Okay. After this loop, what will happen? My current will be at my tail position. Now you can say, sir, why are we doing so much drama? Why can't we just keep the tail also? Just like how we are keeping head. Similarly, we can keep the tail also. That is a very good idea. We can do that also. Hold that thought. We will come to that little bit later. But if we keep track of tail, then we don't have to traverse so much. Okay. So once this is done, then what will happen? This current pointer will be at my tail. So if it is at my tail, then I can say current dot next. Current dot next is equal to, we want to insert the node. We will say new node.
But if you want to keep the tail position also, that for that time also we need to at least traverse once, right? To get to the
We have to
traverse one till the end, right?
We will get to that. Tail wala part abhi chhod dijiye.
So instead of in the while you have written current dot head, it should be current dot next, na?
Sorry. Thank you. Okay? Logic is clear. Now what will happen that when we have added one new node, so what has happened? Linked list का जो size है वो एक increase हो गया. तो यहाँ पे हम लोग एक चीज कर देंगे कि we will say that size is equal to size plus 1. If you are keeping track of size, which is a good idea. This logic is clear, guys, to everyone. This block of code you will be doing very often, almost always. By the way, you don't have to implement linked list from scratch. Okay, sometimes you will get it as a question, but normally you will not get it as a question. But this implementation is very important. Unless you do it, you will not internalize linked list. Okay, that's why we will do complete linked list from scratch in Python. Now there is one edge case in this. One edge case is there. What is the edge case? Edge case is there that when I ask you to append, I already gave you some elements, but suppose there are no elements. This is the case when there are some elements in the list. When I say list, I mean linked list. Okay? But if there are no elements in the linked list, then what will happen? If there are no elements,
then we need to create a new list, right?
In the linked list. हाँ बताइए क्या बोल रहा है?
We need to create a linked list, first element, and put the position as a head.
So if there are no elements in the linked list, then what will linked list look like? It will look like this. it will look like that there is a none.
Yeah.
Okay, and the none is only my head. None is my head and none is my tail. In that case, will this code work? This code will not work because current.next, nothing is there. So this loop will never work. Okay, so then what you will do? Current.next is equal to new node. So you will end up, so suppose if I am saying that add a new element called 10 here. So the code that we have written will not work. If I'm saying that I add one element 10, why are the colors getting messed up? I'm saying add a new element called 10. So if you run this code, it will not work. You will end up doing this. Head.next is equal to 10. This you will do. This we don't want to do. So in this case, what we will do? We will simply say that remove this none and take this 10 and make that 10 as head and tail. This is what we want to do when we are inserting the first element. This is what we want to do. Do you guys agree? Okay, so here we can write one else. In this code, we will write one else. This is our else. Okay, and here we will have if. And we will say that if self dot size is equal to 0, or we will write one method which will be कि अगर हमारा linked list empty है, if self dot is empty का method we will write. Is empty will basically tell us if the size is 0. If the size is 0, is empty will be there. Then what we will say? Then we will say that head is equal to node or new node. Head is equal to new node. That's all. Okay. And size is equal to size plus 1. Here also we are increasing the size. So 2 times we don't want to write the same line. So I will take this line and इसको यहाँ डाल देंगे. This is our indentation. Okay, and here I will create one new node. New node is equal to node and whatever value you have given, maybe 10. Is this clear, guys? What we have done? We have written the code to append to a linked list. If it is empty, then what will happen? If it is not empty, then what will happen? This is the case.
For a new node, creating a new node.
If it is empty, then it is an edge case that we have to handle separately. Otherwise, we have to handle it this way. Clear, guys? So हम is saying if not self dot head, if not self dot head, वो भी लिख सकते हैं क्योंकि जब लिंक लिस्ट एम्प्टी होगा तो हेड नन होगा. ठीक है, ऐसे भी लिख सकते हैं.
सर आपने ये जो बताया करंट इज गोस टू करंट डॉट नेक्स्ट, तो करंट पॉइंट करेगा क्या, मतलब पूरे ब्लॉक ऑफ नोड को?
कहाँ पे? कौन सा? ये कहाँ पे बोल रहे हो?
व्हाइल लूप के नीचे
ये वाला लाइन,
इसके बाद
ये वाला लाइन.
हाँ, तो करंट क्या यहाँ पॉइंट आउट करेगा पूरे नोड को?
नोड को, हाँ. जैसे यहाँ पे आपके पास है 10, फिर है 20, फिर है 30, फिर है 40. तो जो करंट पॉइंटर होगा, जो करंट पॉइंटर हम बनाएंगे ऐसे, वो 10 को पॉइंट कर रहा है. ठीक है,
10 को पॉइंट कर रहा है मींस 10 के एड्रेस के साथ 10 के डेटा को
10 नोड को पॉइंट कर रहा है. ये मान लो कि 10 जहां भी है पॉइंट कर रहा है. ये 10 के पास ये जो ब्लॉक मैंने बनाया है, ये सिर्फ 10 नहीं है, इसमें 10 का एड्रेस भी है. यहाँ पे ये 10 जो है, ये 10 ऐसा है, इसमें एक डेटा है 10 और एक नेक्स्ट है विच इज नोड, ये वाला नोड, इसका जो भी नाम है, जो भी एड्रेस है इसका, नोड 2 बोल दो इसको. ठीक है, एड्रेस हम लोग लिखते नहीं है सिंप्लीफाई करने के लिए. ठीक है, तो करंट डॉट नेक्स्ट विल बी पॉइंटिंग टू 20. So we'll say current is equal to current dot next. Current is equal to current dot next 20 है. इसको current बना दो. So 20 has become current. Current dot next is now 30. Current dot next is existing while loop में. So we will move the current here. 30 dot next is existing, move there. 40 dot next is not existing, then this loop will end. So when the loop ends, current is at tail. ठीक है, उसके बाद
So-
tail में add the new node, whatever you want to add 50. Okay, and then
Sir, while current dot next is the address, right, on the current node.
yes,
Yeah, right. So in this case, current equal to current dot next means the address is pointing to the current, right?
forget about the address.
Uh-huh.
We are not concerned with the address.
No, for example, sir, let us take the node 10, right? We have the two part, data part and address part.
Correct.
Then current dot next is equal to true means, yeah, we have the 10 element, it has some address of the next node. Then loop is iterated. Then current equal to current dot next means how the values is moved from 10 to pointing to the 20. The current equal to current dot next, inside the loop.
This is 10. This contains two things. One is data, which is
Yeah,
10,
next then.
and it contains next, which contains address of this. Let us say that this is node 2. So this will contain node 2. So I
Yes,
will say
correct.
current becomes current dot next, which means this current pointer will now not point to this memory location where this node is stored. It will point to this memory location where node 2 is stored.
Okay. So what is the value of the current? Current is has address or 20 data.
It will not. Why will it have data? It will contain. It will refer to this node. This 20 will again contain data. Imagine it like this, Baba. It is like this. 10, 20, 30. This is the memory location, whatever random memory location, 5000. So this will contain 5000. 5000
Yeah.
contains what? It contains the whole box. This is at 6000. So this will refer to 6000. Okay.
Yes,
This is
correct.
maybe at 1000. So current pointer is like this. It is pointing here. When I say current becomes current dot next, it will go to the memory location of 5000. What is 5000 containing? 5000 is containing this whole box. In this whole box, I am looking at 6000. At 6000 is something there. Yes, go there. But
Okay.
this 5000, 6000, this is only for explaining. This is actually not our business.
Okay. Okay, current equal to current dot next means it is pointing to the entire node, complete
Entire
node.
node, yes, it will point
Yeah.
to the node. When I'm saying this, whenever I'm saying this node, I always mean the whole block, not the data. Data is one attribute of that. Next is one attribute of that. Going forward, I will see that it can have more attributes.
Okay, okay. Got it.
Okay, so whenever I say node, I mean node. I don't mean the data of that node.
Yeah, yeah. Got it. Understood.
Okay, appending is clear, guys.
सर पहले वाले एग्जांपल में लेट सपोज कि हमारा मतलब लिंक लिस्ट एम्प्टी है और हमने उसमें 10 ऐड करने की कोशिश की, तो अगर ये एल्स पार्ट में जो लिखा गया है कोड सेल्फ डॉट हेड करंट इज इक्वल्स टू नन है हमारा, क्योंकि ये तो हेड को पॉइंट कर रहा है करंट, और वाइल वाले लूप में भी नहीं जाएगा, लेकिन उसके बाद वाले लूप जो है करंट डॉट नेक्स्ट इक्वल्स टू न्यू नोड, इसमें तो नहीं जाएगा ना?
जाएगा, क्यों नहीं जाएगा?
तो फिर इफ कंडीशन लिखने का फिर मतलब क्या रह जाएगा?
आप सोचो कि अगर ये इफ वाला पार्ट हमने नहीं लिखा, सपोज मान लेते हैं कि इफ वाला पार्ट हमने नहीं लिखा, हमने सिर्फ इतने से ही काम चलाने की कोशिश की, यही बोल रहे हो ना आप?
हाँ।
तो क्या होगा? अब करके देखो, आपके पास नन है, ठीक है, नन ही आपका हेड है, नन ही आपका टेल है। आप चाह रहे हो कि एक वैल्यू यहाँ पे अपेंड हो जाए, यू आर ट्राइंग दैट दिस 10 गेट्स अपेंडेड। ओके, करंट इज हेड, करंट विल बी पॉइंटिंग टू हेड, सो करंट विल बी पॉइंटिंग हियर।
Yes.
It says while current dot next. Current dot next is nothing.
Yes.
So this loop will never run.
Yes.
Then it will come here.
Yes.
It will say current dot next is equal to new node. So what will happen?
Current is also known. and it will
current
know.
dot next, so none का next will become 10. But do we want this?
हाँ, यही पूछ रहा था मैं कि ये तो करंट डॉट मतलब नन का नेक्स्ट 10 हो जाएगा।
नन का नेक्स्ट 10 हो जाएगा, बट हमको तो ये नहीं चाहिए। हमको तो ये
Got
चाहिए
it.
कि 10 हमारा हेड बन जाए और 10 हमारा टेल बन जाए, क्योंकि पहला एलिमेंट ऐड हो रहा है।
समझा? ले
लिंक लिस्ट में अगर कुछ भी नहीं है और हम पहला एलिमेंट उसमें ऐड करें, तो वो एलिमेंट ही मेरा हेड बन जाना चाहिए।
Got it.
और अगर कुछ है एलिमेंट, तो उसके बाद वो एलिमेंट ऐड होना चाहिए। लेकिन अगर कुछ नहीं है तो वही एलिमेंट हेड बन जाना चाहिए। अदरवाइज मेरा जो हेड है वो नन होगा, तो मेरा जो लिंक लिस्ट है वो ऐसा दिखेगा, ऐसा यहाँ पे नन रहेगा और यहाँ पे नोड 2 आएगा, और ये हमारे पास यहाँ नोड 2 रहेगा। ऐसा नहीं चाहिए मुझे, पहला एलिमेंट हेड नन हो जाए, ऐसा नहीं चाहिए। इसलिए वो उसको अलग से एज केस था, उसको अलग से हैंडल किया। ये क्लियर हो गया क्या?
Yes, sir.
कैन वी राइट दिस कोड? Should we write this code? Guys, I hope all of you are understanding. I don't want anyone to feel disconnected. Okay? One more thing here. That what will be the time complexity of this?
So now
What will
each
be
and
the time
every
complexity?
element
Often.
in the order O of n only.
O of n.
N.
Why? Because you have to traverse till the tail. You have to traverse till the tail in order to append it. Okay? But if we keep track of the tail pointer, then it will be O of 1. Keep that in mind.
Yeah, directly we are going to that point, right? Not traversing.
If we know tail pointer, then we don't have to jump to go to tail pointer. Then O of 1. But this part we have not discussed, but I will write it here so that in notes when you will see later, then you will get to know. Okay, इसका कोड लिखते हैं।
एक बार can you scroll up? How do you, I want to see how do you create a node? No, in the program, Jupyter notebook.
We'll write.
Data and okay.
इसको मैं यहाँ डाल देता हूँ, ठीक है?
And class name for naming convention, you are written linked list. अब कुछ भी हो सकता है ना उसका?
कुछ भी हो सकता है, आप यहाँ पे डाल दो माई लिंक लिस्ट।
हाँ।
मेरा मर्जी है ना, मैं कुछ भी डालूं। Okay, we'll do append. Okay, so here there are two cases. Okay, if the linked list is empty, then put the new node as head, then assign the new node as head. And case 2, if there are existing elements, then traverse to tail and set new node after tail. This is all we will do. Okay, so first what we will do? First we'll create the new node. Okay, so new node is my node, and this here we will not have a node. You can take a node also, but we'll take a value. Okay, because if you are working with list, we are concerned with the value. List में जब हम लोग काम करते हैं value काम करते हैं. We don't want to work with node. Means from the outside we don't want to work with node. Inside implementation we are working with node and all those things. But the user does not want to know all that. What node you are making and what is your next pointer, current pointer. User will say I have a value, you put that value. And when I'm reading, I will read that value. I don't want node. Node is your Python implementation. Okay, so I'll just create one node called val. Okay, then I will say if self dot is empty. Okay, so for this I have to create a isEmpty method. So I will create the isEmpty method. And I will say return self dot size equal to 0. Okay, so if size is equal to 0, then it will be empty. So if it is empty, then we will say self dot head is equal to new node. Okay, That's all we will do. And if that is not the case, else, then what we will do? We will say that current pointer is equal to self dot head. We will start with the head pointer, and then we'll say while current dot next. While current dot next, we'll say current is equal to current dot next. When this loop will end, when the loop ends, the current pointer is at, what is this? Is at tail. Okay, then we will say current dot next is equal to new node. Okay, after both cases is done, then we will increase the size of the linked list. So we'll say self dot size is equal to plus equal to 1. Guys, did you understand the append code?
Yes. So the current dot next means the entire node, right? Of the current entire of the next node.
Yes, yes.
Yeah.
Current is the node, head is a node, everything is a node.
A node only. Okay.
If I want to look at value, then I will say current dot data. Dot next and dot data are two attributes of the current node.
Yeah, the self dot get means that is initial node. It is pointing to the current object. Then current dot next means it is pointing to the next node or current node. That current dot next.
Where? Sorry, where?
No, the after else block. After else block, right? Current equal to object. Current equal to self dot head. Self dot get means a current node.
Yes.
Yeah. Then while we are making a iteration, right? Current dot next. It is pointing to the next node or current node. Current dot next. The while loop. No, one side one.
No, it is presently checking whether it's a next one or not. The 30th line is asking, or 29th line is asking. It's checking with the
I'm asking the line number 29, sir. 29.
29 is checking if you are having a node like this.
And
this is your current pointer.
Yeah, correct.
What is current dot next?
Yeah, that is the 20 or 20 only, right?
20? Node of 20?
Yeah, node of 20, yes.
Node of 20 is
Correct.
existing, right? It is not none, correct?
It is not none, yes.
So if it is not none, then I will move the current pointer from here. I will move it to here.
Okay.
Now what is current dot next? If this is current, then what is current dot next?
30.
30. 30 is existing, correct?
Yeah, existing.
30 is
Yes.
not
Then
none.
it is none.
So I'll move it here. Now what is my current dot next?
None.
None. So if it is none, then this loop will stop, which means I am at the tail. This 30 is the tail, correct?
Yeah, that is the tail, correct.
So this whole drama, why did we do? We did that to reach the tail.
Okay.
Why do we want to reach the tail? So that we can attach some new element to the tail.
Okay. Understood. I think the outside line number 32 will be executed as script. Yes, correct.
Okay. Can we now implement this and add some things to our list? I want to say that my list dot append. I want to append 20. So now if I look at my list, you see, we are not able to visualize what we have created. Do you guys understand? We have created a linked list. We have added something, but there is no way for us to visualize it. So so for example, if you create a list in Python like this, list 1, okay, you say 1, 2, 3, 4. Then if you do this list 1, you are able to see the list, correct? That, okay, it is having 4 elements. Is it not?
Yes.
So it will be good if we can create something like this for our linked list also, so that we are able to visualize it. Okay. So how can we visualize it? Unless we can visualize it, we don't know whether this append method is working or not. Actually, it is working. What we can do here is we can come here and we can say my list dot head. So it is giving us this, again, it is referring us to a node. But if you look at data, it is giving us 20 because 20 is what we have appended. But this is very painful process where we are not able to figure out this is none. Okay. So actually we have created one linked list like this. This is 20. This is our head and this is our tail. And this is none. This we have created, but we are not able to see it. Do you guys understand the problem? Can we solve that problem using our knowledge of linked list and object oriented programming? Guys,
Yes, yes, yes. We are
can we
doing.
write a traverse method? Traverse method will traverse the list and collect all the elements. Okay, so what I will say that I will take elements is equal to empty list. I will say current is equal to self dot head, and while current dot next, I will say elements dot append
Dot append.
current dot data.
Mm-hmm.
Okay, and I will say current is equal to current dot next, and then I will return elements. There will be one
Okay.
edge case here, which will be if the linked list is empty. If not self dot head, or I will say if self dot is empty. If current is equal to, I think it will work otherwise also. No need of that. Current is equal to self dot head. If current dot next is not there, which means current is none. So if it is none, no, then it will be a problem. So we'll say if self dot is empty, then we will return empty list. Okay. So if we do this, and now I'll come here, okay, and now I'm having this my list. And I'll say my list dot traverse. This method I'm calling. What I'm getting empty. Why I'm getting empty? I appended 20, no? So then I should get something. What happened?
We should rerun it.
Current is, acha, we have to, I think we did not run it. No, what happened?
Sir, is empty is a function line number 38.
Thank you. अभी भी नहीं चल रहा? क्या गलती कर रहा है? My list dot. What is the mistake? Append, so we have done if self dot is empty. If self dot is empty, let us check. If that condition is getting executed, let me print here. List is empty. Elements dot append current dot data. Current is equal to self dot head. Print current dot data. Current dot data is coming. Then while current dot next. Oh, current dot next is not there, no?
We need to give head is equals to current is equals to head dot next. Sorry, head current is equals to head.
Sorry. This should be while current. Sorry, not current dot next. Sorry. Okay. So now can we append more elements? Did you guys understand what mistake we did? Yes or no questions? At least you should respond fast here. 40. And I'm saying my list dot append 50. So 3 elements I have appended now. 3 elements I have appended. So now if I traverse, let me remove the print statements. This print statement is fine. This line is not needed. You see, now if we traverse, you see, we are able to see our linked list like this. So it looks like, okay, it looks like a list, but it is actually not a list. It is what? This is a linked list. Okay. Or a list, you can say it is a list representation of our linked list. Ideally, we should not use this traverse outside. I don't want anyone to use this traverse outside. So I can make this as a private method. Okay, I don't want to use this traverse outside, but I want to create one visualization for my linked list. What I will do, I'll say str, or I will say repr. I'll create one repr method. And I will say self, okay, and I will say elements. I will say list of elements is equal to self dot traverse. Now you see this is encapsulation. This method I'm encapsulating from outside. In Python, this is just an indication. Someone wants, they can traverse it, but it is not advised. Okay. But I will do list of elements here, and then I will return. I will say one arrow dot join list of elements like this. So if I create my linked list now, and then if I just say my list, what happened? Steering pins dot join. You see, this is how we have now created our linked list. We are able to visualize it. Are you guys able to see? And if you want, you can do one plus arrow, none here. So this is our linked list now. This is just a way for us to visualize it. Okay. Now if I want to add something, I will say my list dot append 100. And again, if I do my list, we are able to see 50 ke baad 100. So now whatever we do, we will be able to see it. Guys, all of you are with me so far?
Yes, sir.
Anyone having any doubt or confusion till here, whatever I have done?
So the one question is self dot get now. Scroll up a little bit. Scroll up. Wait. Line number 48. Yeah. So self head means for entire node, right? Entire of the current node.
Always it will be node.
Always is a node. Okay.
Always.
It's not just segment.
What else can it be? What else can it be? What is the confusion? What else can it be? If I'm saying current, it is a node. Is current ka agar if I want the data, then I will say current dot data. If I want the next pointer, then I will say current dot next. But if I say current, then I'm referring to the entire node always. Okay. If I say head is equal to current is equal to current dot next, Every time I am referring to the node. Every time.
Node only. Okay. Because it has the two segment, right? Data and
Yes, I
address.
am referring to that data type. I am not referring to the node or next. Node and next are two components of that node.
Okay.
Data and next are the components of the node. I am referring to the node. From that node, sometimes I will want the data, then I will use the data. Sometimes I will want the next, then I will use the next.
Okay.
What is the next thing, guys? Next thing, guys, is that I want to write one method to insert something at any random position. Which means that now I have created this. I have created this linked list here. Okay. 20, 30, 40, 50. 20, 30, 40, 50 and none. Now someone is saying that, sir, there is a value called 60 and this 60 should go between 40 and 50. So it should become 20, 30, 40, then 60, then 50 and then none.
Yeah, correct.
So this is what in list we are having insert method, where we are saying insert at index 3 the value of 100. Correct?
Yes.
So this functionality I want to add to my linked list.
Correct.
Problem statement is clear. What we want to do.
Yes.
Can we analyze that and see how we will do it? So here I will come and I will say, first was append. Second method I want to discuss, which is, which color I wrote here? Yellow color.
So are you going to pass the index, which we have value we are going to fit with position? We need to find out the index and
Linked
then
list doesn't have index.
We'll see. In linked list, we don't call it index. Okay. But what you're trying to say is correct. You'll say insert at any position. So it will be like insert and we will give a position and we will get a value. And we'll say at that position, please insert that value. Okay. So what we will do? Suppose I'm having this, it like this, 10. Guys, what is the time? $7:20. Guys, can we finish this in 10 minutes?
Yeah.
Sure. No, right now it's
Sure.
6 o'clock, right? 6:30. Here.
We started late. Are you guys okay?
yeah. So,
Oh,
but there will be one more option. The insert and delete also should be there, right?
everything will be there, sir. One by one, we will come to everyone.
Okay.
Okay. But I want you to start now after insert. When I ask you to delete, in your mind, you should automatically at least frame 70 to 80% of the
Yeah,
logic.
it will
without
be
meeting.
same thing. Yes.
Okay, you will get the idea. So main idea is this chain. Okay, the chain, the link is there, no? This link we have to manage. We have to play around with these pointers and links. We have to manipulate it. You will get to know now what I mean. Suppose this is 50. Okay, and then there is none. Okay, and I have a value called 100. And someone is saying insert position. We'll say insert at position 3 the value of 100, which means this is 0, this is 1, this is 2, this is 3. So between 2 and 3 here we need to insert 100. Okay, problem is clear.
Yes.
If I have to do that, then what I should do? I think I have given you a hint earlier. So I will take 10, I will say 20, I'll say 30, Okay, this is 40, this is 50, and this is none. First, I will create a new node called 100. Okay, and whatever is the position, okay, position is 3, then I will come to this position. I will come to this position. How will I come to this position? I will start from my head. This is my head. And this is
Yes.
my tail. Tail is not important. We will start from the head. We'll start from here. We'll jump, we'll come here. Okay? This is our current. Is this clear, guys? Still here?
Yes.
This is our current pointer. Okay? Then what we will say, what we have to do?
We need to
Whatever
put.
is this new node,
Yeah.
whatever is this new node, this node we have to do something like this. We want to break this connection and we want to bring this connection here.
We can put it 30 dot next equal to 100 and 100 dot next equal to 40.
100 dot next is equal to 40. Now, whatever you said, okay, pay attention to that. What did you say? You said node 30 dot next is equal to node 100. Okay, and node 100 dot next
Dot next.
is equal to
40.
node 40. Correct? This is what you
Yes.
said.
But prior to
Yeah.
that, we need to show the address of 30 dot
Ah,
next.
you got it now. Now we can close the linked list subject. You have understood it. Let us move to next topic. Can we move to the next topic? You have understood it perfectly. Okay. If you do 30 dot next is equal to 100. Okay. If you do 30 dot next, this was connection like this. Like this. Now what you said, I will break this connection. You have broken this connection and you have come here. Then this 40 is lost. This part is lost.
Yes, correct.
Correct, no? So just little bit we have to be careful. When the connection is like this, first we will say 100 dot next is equal to 40.
Yes, correct.
Now this 40 is present. 100 also we know, 40 also we know. Then we can break this connection and we can say 30 dot next is equal to 100. So we just have to do this ulta. All of you are clear, guys? All of you have
Yes.
understood? Insert at any position. One thing we have to be careful. One thing we have to be careful that we need to check. Okay, edge cases. One thing we have to be careful about edge cases. Is that position should be valid. Which means if position is less than 0
Greater than 1, yeah.
or position is more than size, these two cases we have to be, these are invalid cases. Position cannot be less than 0.
But position can be greater than the size, right? Because it will be
How?
like append only, right?
Hmm?
It will become an append, right?
Cannot be greater than size. It can be equal to size. For example, if you're counting from 0, suppose this is 10, this is 20, and this is 30. So what is the size?
3.
3. So this is index 0, this is index 1, this is index 2. So here you can append it.
Yeah, yeah. Okay.
Which
got it.
means 3. But if someone says 4,
Array out of index, like array
then
out.
it will be index error.
Yeah.
So this you have to be careful. Greater than size and greater than equal to size, sometimes it will come. That according to situation, you have to use your understanding and decide that.
The linked list doesn't have index, right?
No.
Then how equal to size equal to 3? Position greater than size.
We have written here, no? Size.
Hmm.
We have keeping
Yeah,
track of
size,
size, no?
Yes, correct.
one more edge case can be there. So whenever we are dealing with linked list, always think of these edge cases, that whether the code that we have written, it will work when the list, when the position is 0, list is not having any elements, list is having only one element. These are edge cases. These are called as potential edge cases, which we have to check always. Sometimes we have to handle these edge cases, sometimes we don't have to handle the edge cases. Okay, but you have to consider once to check position of insertion is valid or not. Okay, is linked list empty? Linked list is having only one element.
The linked list
Okay.
is having one element means head and tail point to the same element, right?
Yes.
Yeah.
Okay. One element does not mean that head and tail is pointing to one element. It means that head is there and tail is none.
Not getting, sir. 10 is the one element, right?
If there is,
the first one.
if there is only, if head and tail are pointing to the same thing, it is also possible that the linked list is empty. And
Yes,
if there
correct.
is only one element, then also there is head and tail. Both the cases, head and tail are pointing to the same thing. But this is empty and this is having only one element.
Which is
Okay.
empty, sir? Head is empty?
This one is empty, no?
No, that is empty. But in the below one, head and tail pointing to the same element, right? 10.
Yes. So this is one element. Linked list is there with one element.
Yeah, but
Here,
yeah. Yes,
here
sir.
the size is 0. Here the size is 1.
Equal to 1. Yeah.
Okay.
But it's pointing to none, right? The
Which
10 element 10 is pointing to none as well. That
Yes.
next one, yeah, none.
That's why there is one element.
Okay. So
Here
in
there
this
are
case,
0 elements.
in this case, we have only one element means head and tail is pointing to the same element, 10 only.
Correct.
Okay. Yeah.
Okay.
Got it.
Linked is having only one element. While inserting or deleting. Okay. PO if position is equal to 0, which means you are trying to delete from the first position. These are some potential edge cases which you have to consider.
Okay.
Okay. For example, in this case, you are trying to insert something. Okay. But if the linked list is empty or if the position is equal to 0, here if position is equal to 0, okay, will this code work? That you have to think. If position is equal to 0, then what we will do? Whatever code we will write or whatever logic we have decided, what logic we decided? That wherever we want to insert 1 before that element, we will come. Okay. And then that current dot next, we will do. The new node will be current dot next. So this logic, if you want to write, what is this logic? What is this logic? We are here at
Then
current.
current equal
We are here at
equal
current.
to
So what we are saying? New node.
current equal to new node.
We are saying this new node dot next. This line I'm saying 100 is what? New node dot next is equal to what?
Current
Dot next. This 40, no, this 40 identity is what? This 40 is current dot next. It is like this. We are having like this. So if this is current, then this is what? This is current dot next. And this is our node. Suppose not
Yes.
new node, let us say node. Then what did you say here? You said 100 dot next is equal to 40. 100 is what? Node. Node dot next is equal to current dot next. Which means this connection we have made. Once we made this connection, then what did you say? You said 30.next is equal to 100, which means current.next is equal to node. Current.next
next equal to.
is equal to node, which means current.next is equal to node, which means this connection. If we make that connection, then this connection will be deleted. So this is the operation we are doing, and we have inserted something. So size will be equal to increase by 1. Okay, but before this, what we have to do? We have to come to this 30. This current should arrive at 30. How will it arrive at 30? We will start with head and we will jump 2 times. Correct?
Yes.
So let me write that code properly. Are you able to get the pattern of thinking, guys?
Yes.
This logic will be applicable. First, we have to reach this current pointer here. So what we will do? We will say we'll create the node. Node will be equal to node, whatever value has been given. Okay. After that, what we will say? We'll put the current pointer on the head. We'll say current is equal to head. Okay. After that, we have to reach the node before the position. Okay. So we'll run a while loop. We'll say while. Okay. Or you can also use a for loop because you know how many times you have to jump. So we can say for index in range, and we have to go 1 before position. So we'll say position minus 1.
Yeah.
And we'll say current is equal to current dot next. Did you guys understand this?
No, where is the position value, sir? Position is a size.
Position is the value which they given, right? Which position we have to add it.
Where you have to insert, that will be given by the user.
Okay.
Okay. And one more thing here we have to add, which is if index, I'm writing pseudocode, if index is invalid, then raise some error. This I have told you that index will be valid when position is less than 0 or position is greater than 0. Okay. Now my question to you is that if suppose we want to insert at position is equal to 0, suppose, okay, I told you that this is one potential edge case, which always we have to think. So we have written this code. When you write these type of codes, you have to do a dry run. Okay, you have to do a dry run, which means you have to, just like how I have done here, you have to do this and you have to show whether it works or not. Okay, so whenever you are doing dry run, not just here, for any other question also, you have to always consider edge cases. So in linked list, I have given you some potential edge cases. These edge cases, if you are showing that my code is working for this edge case also, this also, this also, this also, that means what you have written is a foolproof code. Okay, so here I want to discuss that suppose if I'm having a linked list like this, 10, 20, guys, is everyone with me? Or are you drifting away?
Yes.
How many of you are with me? Only 2-3 people are responding. Always it is Abhimanyu, Ashish, Soham, and Shashwat. Other people are not responding.
Yeah, we are there. Yeah.
We are there, sir.
हाँ, मुस्तफा भाई थोड़ा आप एक्टिव रहो चैट में, कुछ लिखते रहा करो.
ठीक है जी.
हाँ, आप लोग थोड़ा कुछ लिखते रहते हो ना, मैं एक आंख से चैट देखते रहता हूँ, मुझे लगता है अच्छा लोग सुन रहे हैं, तो मुझे वो अच्छा नहीं लगता कि मैं बोल रहा हूँ और बाकी सब लोग सो रहे हैं, वो मुझे पसंद नहीं. ठीक है, नहीं समझ में आ रहा है तो आप बोलना, मैं रात भर बैठ के समझाऊंगा. ठीक है, चलो. So the question is that I want to insert at position 0. So this code that we have written, is it valid? सही है या अलग से इसको handle करना पड़ेगा? That is the question. Normal case में तो this code will work, that I know. बट एज केस में ओके अलग से हैंडल करना पड़ेगा कि नहीं वो देखते हैं. ठीक है, तो यहाँ क्या क्वेश्चन है कि करंट इज इक्वल टू हेड, तो करंट इज इक्वल टू हेड. ओके, एंड देन इट इज सेइंग फॉर इंडेक्स फॉर अंडरस्कोर इन द रेंज position -1. So position -1 will become what? 0 -1 -1, which means this loop will not work only.
Yes, correct.
So then I will say node dot next is equal to current dot next. Okay, so suppose this is 100. Okay, node dot next is equal to current dot next. Okay, and current dot next is equal to node. Current dot next is equal to node. Okay, ये क्या कर दिया हमने? We were supposed to insert at position 0, but we have inserted at position 1.
1.
Which means this code will not work for position is equal to 0.
Yes.
Or that we have to handle separately. Okay.
Yeah.
How will we handle that? What we have to do?
Then
We
in
need to
this
see the
case,
size.
current
If the size
Huh?
equal to 0 or greater than 1.
Sorry.
The size
no.
is greater than or less than greater than 1 or not, we need to see.
So no,
The list is at 0th position, right?
If we have to insert at 0th position, then what we have to do?
node equal to
Suppose I'm saying this is 100 and insert it at 0th position. We know that the logic, general logic that we have written is not going to work. So what we'll have to do? We'll have to create one more if condition here.
the current, yeah, if condition current equal to current dot next, sir.
No.
No.
If we need to see the first we need to create a node, and current dot next should be the present current head of that. We need to replace
Yes.
No, new node equal to current.
We will create. So we will create the new node 100
Yeah.
and I will just add it to the current head. So I'll
Yes,
say
correct.
node dot next is equal to head. Okay, insert.
Yes.
Now
Node
100 will
dot
be the
next.
head of this.
But one more thing we have to do, because head is here. Head is here. Okay, and we have done node dot next is equal to head. So we have created this connection. But now 100 has become the new head. Correct? No? So head has to come here.
Yeah.
Head is equals
We
to
need to move it
node.
here.
Okay, so we'll
no-
say
Mhm.
head is equal to node. These two lines of code we will do. This lines of code will do what? This will do what?
Adding the
This will
element of first separation.
insert at beginning. So we can
Sir,
write a separate method also to insert at beginning. Insert is a general method, but we can say that insert at beginning can be a special case. Like that we can write. Or you can write the code here also. So what we can write here, we can say if position equal to 0, then insert at beginning. और वो कोड अलग से कहीं पे लिख के रख लेंगे. Insert at beginning code is this one.
Yeah, we can create a function here.
We can
Yes,
create a
I
separate
think-
function and we can keep it.
Okay, I think you mean head is traversing to the node dot next, then no current head it is pointing to the new node, right?
I did not understand. Say again.
No, my question is that what is the current logic? Node dot next equal to head means the current head is pointing to the next node. Okay, then second line head equal to node means the
Where
new
are you referring? Are you talking about this one?
yeah,
or
that one
this
only.
one?
No, that one only. The previous one, yeah.
This one?
Yeah, this one, yeah.
1 or 2?
One.
1. Okay, tell me.
Yeah, so what you did means the what is the current head it is moving to the node that next, right? Then new node it is pointing to the head.
New node is pointing to the head, correct?
Yeah, that's why you are interchanging the elements there.
No.
No, sir. Actually, insert at the beginning case, right? Insert at the beginning case, the current that node that next equal to head means the current head.
Wait. I'll create a third case here, which is insert at beginning. Okay, this is a special case of insert. Okay, what will happen here? Very simple. I will give you a linked list. and I will say insert in the beginning a new node called 100. Insert in the
Correct.
beginning means what? What we will do?
We need to 100, then is point to the 10.
So we need to pass the address of 10 to 100.
This is my head and this is my tail. So I will simply, the purpose of doing so much of abstraction is that simply I can say that, sir, I will make this connection. Once I make this connection, this 10 is no longer my head. Is it my head? Now, no, head is the first element. So first element is this, so head will come here. So what did I do?
Yeah, correct.
What did I do? This is my node.
This is a node.
So I
yeah,
said
new
node dot next is equal to
head.
my head. Currently my head is here. So I have made this connection. Then I will say head is equal to node, which means this will come here. It's as simple as that. Done.
Yeah. So instead of the head, we can also call it as current as well, right?
No, current is just a temporary variable that we use to shift. Head is always fixed.
Head
Current is a
fixed
temporary
permanent.
pointer. Like in binary search, we were doing left and right pointer. Like that. It is a temporary
Okay.
variable.
So otherwise, yeah, current equal to head, then we can find as the current like this. Okay.
Why will current come here? There is no need for current here.
Oh,
We are
need,
not doing
okay.
any
Yeah.
iteration. No. Why do you need a temporary variable?
Yeah. No, if you want, we can add like this, right? Current
You
equal
can
to head.
add, you can call it a current, but it will not solve any purpose.
It's not necessary. Okay, got it.
When we will use current, when we have to reach this 30, suppose you want to reach here to do some operation. So then we will start here and we will jump like this and like this. So then this
Correct.
person who is jumping, we will call him temp, or you can call him current, and we'll say current. That current is a temporary variable.
Understood. So I think in the linked list perspective, we have the head and tail is a permanent variable. We can use those
Not permanent.
variables.
Those are not variables. We call them, those are pointers, but they are fixed. But they can change also. Head can change also. Suppose I want to remove this. We will see that when we want to delete some element. Suppose the fourth operation that we want to do is delete from beginning. Okay. Delete from beginning. So delete from beginning means, guys, it's a 7:44.
Yeah.
So इतना जब हो ही गया तो 15 मिनट और बैठ जाएं.
We can
sir,
finish this. We can finish this one, sir.
So basically, head is like a bookmark for us.
Bookmark, you can say like that. Okay, so what you have to do? I have given you intuition of linked list, how we have to implement it. Okay, and I have implemented this traverse method and append method, and I have given you the code to visualize how linked list is visualizing. This much code I have given you, and I have written the code here for insert. So your assignment will be to implement this insert method.
Delete also, you can, on the same lines, you can do it, right?
Sorry?
Delete is also similar to insert only, right?
Similar to insert. Now, very quickly, we will understand everything. And you will have to write the code. I will not give you the code now.
Yeah.
Okay, you have to write the code, and next class, one of you have to explain me. You have to give me a walkthrough.
Yeah.
Okay.
Sure.
So now delete. Suppose 10, 20, 30, 40, and 50. Someone is saying that delete from the beginning. Delete from the beginning means delete, and here this is the head. This is the head, and this is the tail. Now someone is saying delete something from the beginning, which means that this 10 has to be deleted. 10 has to be deleted. Then how will we delete 10?
Delete from the beginning means the first element you want to delete. Okay.
I want to convert this list to this list.
I think in this case, current of next equal to head. We need to point to that. Head has to change.
20 as a head.
Simply, we will move the head here.
Move to the head to the next element, next
Done.
node.
And chapter close.
So 10 is still in the memory, right?
रहने दो, उसको कोई फर्क नहीं पड़ता. हमें तो लिंक लिस्ट से मतलब है जो हेड और टेल के बीच में. हेड से पहले क्या है उससे हमें मतलब नहीं है, हम पीछे ऐसे जा भी नहीं सकते। लिंक लिस्ट में हम सिर्फ आगे आगे ही जा रहे हैं अभी तक।
मतलब वो
This
जंप
automatic
क्रिएट नहीं
garbage
करेगा,
collection, sir.
सॉरी,
This automatic
जंप
garbage
क्रिएट
collection.
करेगा।
1% प्लीज।
Sir, I'm
No,
saying
it's,
that if 10 is there, then it will create junk in the memory over a period of time, right?
That Python's garbage collector का job to remove 10. So head was pointing to 10. Here there was a head, and head was pointing to 10. So in Python keeps track of if there is a memory location where this 10 is stored. So how many people are referring to this 10? If nobody is referring to this 10, there was only one reference which was head. That head we have removed. So now nobody is referring to 10. So after some time, Python garbage collector will come and it will take 10 and it will remove it. If there is
Okay.
no reference for 10, it will be taken care of.
I think, does it have the automatic garbage collection or what about, sir?
It has the automatic garbage collection.
After our programming termination or during the program execution as
It
well?
does not
Automatic?
concern us. It's not of our concern.
Okay.
How Python will do garbage collection, that is not of our concern. If you are very concerned, then you can put this 10 to none, and or you can delete this node from
We
the
can
memory.
also delete. Yeah,
You
we
can
can
delete
also
this
delete.
node from the memory. That also you can do.
Yeah. And also look like any node, right? Any node can have the multiple reference, right?
Yes.
Multiple reference. For example, let us say 20 node number 20, we can have the multiple reference. Maybe 10 or 15 to 18, it can point to the 20 anyway, right? The multiple root elements.
Yes.
Okay.
Delete from beginning is clear, guys.
Yes.
Let us say
Yeah.
we have to delete from any position.
Based on position.
Delete from any position. So what will we do? Suppose this is 10, then I have 20, then I have 30, then I have 40, then I have 50, and then I have none. So if I want to delete this 30, what will you do? I will say delete, and I will take a position. Position I will give you 0, 1, 2.
We need to iterate that.
Can we say that we will come and sit on this node? Okay, this will be our current node. How we will come here, that you know that we will start from head and we will jump and jump and we'll come to 20. And we can say that current dot next is equal to current dot next dot next.
Yes.
Because this is current, then this is current dot next, and this one is current dot next dot next. So this, if we do this, then what does it mean? That we have done 10 and then we have 20. 20 ka next becomes 20 ka next, which means 40. Or you can say that, let me make it like this. It was 30 and then it was 40 and then it was 50. Now current 30 का जो next है, okay, 20 का जो next है, we are saying it has become like
Finding to
this.
the party.
Dot next dot next. So it has become like this. So this is our new linked list.
So in this case, 20 and 30 is still pointing to the party, right?
Yes. But 30 is
multiple
pointing to
reference.
40. That is not our concern. It is not going to make any difference.
Mhm. Yeah. So what is the fundamental concept mean? Party can have the multiple reference, but party should have the only one pointing to the next one node only, right?
40
The
can always
outcome is
point to one node only because there is only one next pointer for 40 node.
only one next pointer, but we have the multiple reference.
That is that 40 can have any number of references. Any Python
Oh,
object can have any number of references.
Okay.
Did you guys understand this? Will you be able to write all this code?
Yes, we can write.
And here you have to consider what again? Edge cases. Position should be valid.
Position equal to 0.
Which means position if less than 0 or position greater than equal to size. If position is equal to size, then also it is not valid. In delete case, in insert case, position greater than size was valid, but here it has to be position greater than equal to, because 0, 1, 2, 3, 4. If position equal to,
5.
how many elements are there? 5 elements. If position is equal to 5, then there is no sense of deleting because there is no fifth element to delete. So here there should be position greater than equal to. ठीक है? Position should be valid and check if the position equal to 0, then whether this code will work or not. There is one more thing, one more edge case here. That if position equal to, if size equal to 1, then what will happen? If the size is equal to 1, if there is only one element in the list, then what will happen?
So size equal to 1 means position equal to 2, right?
Size is equal to 1 means that there is only one size. The size is equal to 1 means the size is equal to 1.
Yeah, correct. Size equal to 1 means we have the 2 node or 1 node? 1 node, right?
Yes, that's why size is equal to 1, no?
No, actually in the above diagram, you pointed to the first node as a size equal to 0, sir. That's why confusion.
This is a normal, this is a general case. I'm saying these are the edge cases.
Edge cases, okay.
Suppose there is only one element.
One element equals size equal to 1, that.
There is only one element in linked list. Okay, which means that ये है, इतना है. This is 10, this is head, and this is tail. And someone is saying, delete this. Delete from beginning. Delete at position or delete this element. So if you will delete this element, then what will happen?
It should stop working too.
You cannot use the earlier code. So you have to use the code that if size equal to 1, then head is equal to tail is equal to none. We have to convert this to like this.
Size.
Clear?
Clear.
Okay. S equal to 1 means head, tail equal to none. Yes, great.
There was only one element. We removed that element. Now the linked list is empty. Linked list is empty means this representation. So
correct.
whenever someone is asking you to write an implementation of linked list, these methods you have to implement and this logic you have to keep in mind. Now there is no need to memorize it. I hope the way I have explained it, you don't have to memorize it. You will draw it and then you will understand which connection, where it has to come, what are the potential edge cases, all those edge cases are being handled or not. Guys, have you guys understood linked list ka basic?
Yeah. Yes. So I think while we are making insertion or deletion or appending, we can navigate from the head or tail only.
Yes.
Yeah, we should not have any we should not directly take action in the middle of the element.
You will not have it because we have implemented linked list. What do you have in a linked list? You don't have anything. You have only head.
We does not have index. That's why
Yes.
it's a slower. Yeah.
Now, in this linked list, what more things are there? We can have few things here, which is linked list with tail pointer. 8 बज गया क्या? 4 minutes है. Linked list with tail pointer. And there is something called as doubly linked list. And there is something called as circular linked list. Okay, circular linked list is not used much. Doubly linked list we will see, and doubly linked list will come in very handy going forward when we are learning about queue also. And linked list with tail pointer. Okay. So what will be the benefit if we have a tail pointer also? Suppose if we create a linked list. In the Python implementation that we did not have tail pointer. But suppose if we keep a tail pointer also, then what is the benefit? If this is my head,
will be up and
if
will
this
be
is my tail,
quicker.
guys, please pay attention here. When I told you to insert something here, insert in the beginning, suppose I said insert 100 in the beginning. Insert at beginning. What do you think is the time complexity of that?
Order upon.
O of 1, constant time.
Yeah.
Because no matter how long is the list, if I want to append, I have to do only one operation. But if I have to insert at end, which is also called as append, then
Yes.
that is O of n.
Because end is
Because we have to start from here
traverse till an end.
and then we have to jump 1, 2, 3. We have to come here and then we will do. But if we keep track of tail,
Then it will be O of 1 because directly you can go and insert.
if tail is maintained.
Hmm.
So if tail is maintained, then both ends we can append with O of 1. What happens in a list? If you want to append, it is O of 1, amortized. Okay. But if you want to prepend, or you can say append, insert at 0th position, if you want to insert in the beginning,
O of n because we need to
insert at 0, then it is O of n. But in linked list,
it's reverse.
it is possible to do this in O of 1. It is possible to do this in O of 1 if tail pointer is kept. So there is a benefit over list. Correct, no? Do you guys follow?
So not getting second point, sir. Prepend or
Arre yaar, in a forget about prepend.
okay.
Just take insert. Prepend means insert in the beginning.
Insert at tail and beginning and end should be quicker. Yes, correct.
If in a list, if you want to append something here, then it becomes O of n, right?
Yes, so upon
That's what I'm saying. But in a linked list, if you maintain a tail pointer, sorry. This line will come here.
Yeah.
All of you understood, guys? Now you will say how to maintain the tail pointer. We will maintain the tail pointer just like how we are maintaining the head pointer. Suppose we'll say insert in the beginning. When we are doing the linked list, we are doing, when we are creating the linked list. Okay, see these things, nobody will ask you. Okay, but I'm showing you these things to implement from scratch just so that your understanding of linked list is very, very clear. We can directly start solving problems also just by doing the theory. But if you do this, you will have a lot of confidence on pointer manipulation. It will become second nature to you. So we did init method here. Okay, something, and we said head is equal to none. We can also keep track of tail is equal to none. So what will happen when we are creating the linked list? Suppose we are having one linked list here, 10, 20, 30, and 40. So we will keep track that this is head, this is tail. So when we are inserting in the beginning, I told you that this 100 will point here and head pointer we will move here. Similarly, when we are appending, suppose 200 we are appending. So we'll append here tail.next is equal to 200 and tail pointer also we will move. So now after appending, we have the new head and we have the new tail. Clear?
Yeah.
Okay. Till now, if you are having like this 10, 20, 30, suppose, and 40, and suppose 50, and suppose 60, and suppose 70 and suppose 80. This is a linked list. And someone is saying that, boss, I want to insert something here. I want to insert a new element here. So what you are doing? This is the head and this is the tail.
We are traversing for the first.
You are traversing from head, starting from head. Okay. And then you are jumping, coming here. Correct?
Yeah, we can come there.
Yes.
Okay.
But if you have the tail pointer also,
It will be faster from the back side. Yeah.
then you can
Yes.
traverse, jump from here also.
Yeah.
So you can check that if the position is less than half, then start from the head. If the position is more than half, then jump from the tail. You have two references, head also, tail also.
Mm.
Understood the idea, guys?
Yes.
हाँ
इतना तो लिंक लिस्ट अगर इतना समझ में आ गया तो आपको लिंक लिस्ट समझ में आ गया. एक और लिंक लिस्ट होती है जो हम लोग थोड़ा नेक्स्ट टाइम डिस्कस करेंगे. आज आई थिंक ऑलरेडी टाइम हो गया है, विच इज डब्ल्यू लिंक लिस्ट. ठीक है, तो डब्ल्यू लिंक लिस्ट बहुत इंटरेस्टिंग टॉपिक है. डब्ल्यू लिंक लिस्ट विल कम अगेन इन क्यू ऑल्सो. We'll try to discuss W linked list little bit later, but as far as theory and Python implementation of linked list is clear, I think we should be good.
So will
Okay.
you
Well-
discuss this in YouTube session or weekend session?
Which one?
W linked list or the next
Weekday
topic?
session.
Everything we will say. Everything we are covering in class. Live session, we are only doing practice. Question solving.
Sir, and one more concern, during weekday session, we are not able to talk anything, sir. Only we can ping in the chat only. Is there
That
any
is how YouTube
alternative?
live is. What can I do?
Yeah, because we are not able to interact. That's why I'm asking.
I try to answer every single chat that comes.
Hmm. So
I
will you
mean-
be continuing the same topic over weekday session or weekend? This one, the doubly linked list
The
or
class
other.
will go on how it is going normally. Today we have done linked list. Next class we will do some practice on linked list. Then we will go to stack. We will study the theory of stack. We will do problems on stack. Then we will go to queue. We'll do the theory of queue. We'll do problems on queue. Live
Okay.
sessions which I am doing, in that we will do some extra questions. Okay.
Okay.
So linked list, if in the class, if I am doing 3 questions, then 3 more different questions I will do in live session so that you get more practice. That is the idea of the live session.
Yeah. Okay.
It is not a continuation of our class. Our class is going as and how it is going.
That is a practice session.
It is
only
an
then.
extra practice session, more questions.
Okay.
If I don't do those live sessions, then those questions you have to do as a homework. Okay.
Okay. Yeah. that
So
is
I'm
fine.
trying to solve that homework also in a live session. That is the whole idea.
Yeah.
Okay. If you have your
Yeah.
friends and some other students, you can share that live link with them also. Everybody can join. It's for free.
Good question.
Sure.
Sir, another point, before doing the live session, can you tell in advance what questions exactly will you pick up so that we can try it ourselves first and then
मैं
second
खुद ही
pick up?
लाइव सेशन से आधा घंटा पहले डिसाइड करता हूँ यार. इतना मैं बता दूंगा. चलो अगर मुझे पता रहेगा तो मैं
थोड़ा प्रैक्टिस हो मतलब हम लोग खुद हेड अपना दिमाग लगा के आएंगे ना तो थोड़ा ज्यादा सही रहेगा.
बता दूंगा. मैं ट्राई करूंगा. मैं खुद ही इतना ज्यादा मेरे पास भी टाइम नहीं कि मैं इतना प्लान करके चलूं. वो तो 9 बजे होता है तो मैं 8:30 बजे बैठता हूँ. एक रफली देख लेता हूँ कि अच्छा ये 3 क्वेश्चन.
सर ये वाला कोड आप अपलोड कर रहे हैं ना रिसोर्सेज में,
कौन
डैशबोर्ड
सा?
में, ये वाला या
नहीं
मतलब
करूंगा.
अभी का जो लिंक
नहीं करूंगा यार. ऑफ कोर्स करूंगा. आपका लिए यही कोड है. ये सारा कोड तो अभी तक अपलोड किया, तो ये कोड भी अपलोड कर दूंगा.
Sir,
ये जो नोट्स है ये भी मैं अपलोड कर दूंगा. इसका अगर एक्सप्लेनेशन चाहिए तो मेरा यूट्यूब पे जो वीडियो है लिंक लिस्ट का 3-4 घंटे का वीडियो है, उस पे मैंने सारा कोड भी लिखा है
sir,
और वो
don't you
कोड भी
hint-
मेरे गिटहब पे अवेलेबल.
hint दे मत दो सर, ये होमवर्क करेंगे ना हम लोग इनसे.
हाँ, आप करो होमवर्क. मैं इसलिए बोल रहा हूँ आप खुद से लिखो. जब खुद से लिखोगे ना तो आपको जब वो कोड चलेगा ना आपको बहुत मजा आएगा. आपका इंटरेस्ट बिल्ड होगा. फिर नेक्स्ट टॉपिक आप और मोटिवेशन के साथ पढ़ोगे. तो कोड लिखना बहुत इंपॉर्टेंट है. आप खुद से कोड लिखो. अदरवाइज कोड अगर आपको चाहिए तो मेरे गिटहब पे भी आपको मिल जाएगा. आप ये वाला जो वीडियो है आपको अगर और डिटेल में डिस्क्रिप्शन चाहिए तो जो मैंने आज समझाया यही चीज मैंने फिर से एक बार समझाया है, वो भी आप देख सकते हो अगर आपको. दिस वीडियो इज देयर. Okay, so this video again I have explained everything. You can see here. whatever I've shown today, magic method, maintaining a tail pointer in linked list. It is also an interview question. It is also a lead code question. Okay, so I've explained this, maintaining a tail pointer. Doubly linked list also I've shown you. Doubly linked list we will discuss in the next class, but you can watch this video. Very detailed. I've explained everything. I have done some MCQ questions also, like in GATE exam and all, what lead code questions are asked from linked list. That also I have solved. And 3 lead code questions also I have solved here with a lot of detail. Okay, so you can watch this entire video. Iska bhi notes is there. That notes is also available. The code is also available. You can see this is the code. Okay, whatever I've done in class, same thing, but more detail. Everything is, you can see entire code is here. So whatever methods I've told you, insert at position, delete from beginning, सारा code लिखा हुआ है, but you try to write on your own. Okay, you try to write on your own. And if you want notes, notes is also here. Class notes also I will give you. Okay, see this full notes also there. This also you can refer. That also you can refer. The class code also, everything I will give you. Okay.
Okay.
Yes. Okay.
Sir, I have 2 questions, sir. The first question is that do we also update the element in linked list? Updating process.
Yeah, you can update.
Okay, but we didn't see any examples on those, right?
From how much I have explained, you should be able to do it, no?
Okay.
If
Then
I'm saying that,
yeah.
if I'm asking you to update something, suppose this 30 you want to update to 40. What will you do?
Yeah.
You will jump here,
Yeah.
and then you will say node dot current dot data is equal to 40. Set it.
So node dot. Can you write it? Yeah.
You will start from current, and you will jump here. You will come till current. Current dot data is equal to whatever is the new value you want to update. You update it.
Oh, current data equal to new value. Okay, fine.
I have given you the basic structure. Now you can do whatever you want from that.
Okay. Then final example is a tail pointer navigation, right? If you want to backward navigation, that is part of the doubly linked list, right? It's
Doubly
not
linked list, correct.
Okay. We should not make with our normal linked list.
No.
So in this case, we can directly go with the doubly linked list, right? The backward and front forward.
Yes. This I said that you can jump from tail also. Sorry. This from tail that I told you, this will be possible in doubly linked list.
Yeah, we can directly see the concept doubly linked list.
If you can iterate from head or tail, okay, this is a doubly linked list.
Yes.
So doubly linked list is nothing. It is linked list only, whatever we have studied. Just that between the nodes, there will be double connection. So till now we have seen like this 10, 20, 30, 40. Okay. In doubly linked list, there will be one connection like this also. So when we will create the node for doubly linked list, we'll create it like this. We will have data also. I will explain it in detail in next class.
Yeah,
but
right.
we will have data also. We will have next also, and we will have previous also. So if you are standing here in a singly linked list, you can only jump like this. Correct, no?
Yeah, right.
But if it is a doubly linked list, then you can jump like this also, and you can jump like this also. Front also you can go, back also you can.
Yeah. So you're right, sir. But why do they have the 2 concept? No, we can have the doubly linked list to achieve the both.
It will take more memory. Writing code for doubly linked list is more.
Yes, 2 sides, right? It will be faster to access, but memory will be more.
Memory will be more, and writing code will also be more complicated because till now you are managing front next pointer. Now you have to manage back pointer also.
Yeah.
So all the code that we have written, in all the code, 2 or 3 lines will increase. We will discuss it in detail. Don't worry. We will take time and we will discuss it in detail.
I think this is like cyclic. This anti-cyclic, cyclic.
No. Cyclic is not related to this. Cyclic is
not right. Clockwise and anti-clockwise direction.
You watch that. If you are very curious, you watch that video. In that video, I have explained it. I will explain it again in the next class. Okay, guys, it's already very late.
Yeah. Okay, sir. Take care.
We will stop for today, and then I will meet you on Tuesday. Okay.
All right.
Tuesday, guys, please join. Okay.
Yeah, we will join Yeah.
Tuesday
Sure.
9 p.m. we will solve some question on arrays only. We'll continue with arrays.
Yeah. Right.
Okay, chalo.
Thank you, sir. Bye.
Thank you guys. Bye. Good night. Take care. I will upload everything. If I forget, please remind me in the WhatsApp. Okay. Okay. Bye. Good night.
Thank you, bro.
Thank you.